First of all, we're going to talk about GitOps and trying to do a lot of GitOps with Argo CD and Crossplane to allowing us to deploying our infrastructure as well as our applications and as well as third-party services that we're going to talk from there as a services. Okay, a little bit of a presentation. My name is Bruno. I work here at Omnibiz. I'm here DevOps team lead. I've been working here for about 5 years. I've been doing DevOps for at least 7 to 8 years from now. My main challenging or my main focus here is to provide the technologies and the methodologies and the workflow to allow DevOps to be implemented in a company. We have been doing a lot of pipelines, a lot of observability, a lot of monitoring, and a lot of DevOps workflow as well, since the development until the production. This is me. So, digging right in the presentation. So, what is GitOps? Anyone knows what is GitOps? I think yes, of course, but in detail, someone knows what is GitOps? Put your hands in the air if you know it. Okay. So, GitOps, before anything, is an operational framework that takes DevOps best practices. So, it's a workflow, mainly, in a framework that allow DevOps to that takes the most important things or the most important practices that we have in DevOps and set it up on the workflow that allow us to quickly move from dev to production. Here, the main reason is going fast, going fast and secure and deploy more and more and more every day. So, primarily focused on Kubernetes. So, we can do GitOps on other platforms, on other systems, but is a framework and is a workflow specially defined for working with Kubernetes, of course, because of the opportunities that Kubernetes allow us to do. But it's that, how can I say? Essentially is that it's an operational framework that is based on the key principles, on the best practice of DevOps, and the key principles of GitOps are the following that I will tell you. First principle, it's to starting a GitOps workflow, we have to be declarative. Our code, our configuration, everything that we manage must be declarative. A system managed by GitOps must have its desired state expressed declarative. And by then, we are meaning our code. Our code must be presented in YAMLs, in a declarative language. It's more, when we talk about GitOps, we are more talking about how to do infrastructure using the best practice as DevOps. So we are talking a lot of YAML files. Another principle is to be versioned and immutable. The desired state is stored in a way that enforces immutability, versioning, and retains the complete version history. What this means is that our code and our configuration and our configuration of service, our infrastructures must be versioned and stored in Git. So the immutability will ensure that the same code or the same definitions of configurations that we have defined can run multiple times and produce only the same result, not a different result, only the same result. The third principle of GitOps will be that the changes must be pulled automatically. So when you do a push, sometimes or in standard or classic workflow, when you do the push, some trigger or you will have a webhook attached to your Git repo, and from then some will trigger a pipeline that will do all the workflow and all the deployment and all of that knowing stuff of CI/CD. In GitOps, we must have a tool that ensures that happens automatically. I'm not talking here about continuous integration as well. I'm talking about a system that is constantly pulling our Git repo to knowing the differences from the last commit and the last one. And the tool that we are using today will be Argo CD, so I printed an example of Argo CD. The fourth principle will be that it must be continuously reconciled. And that is the main point of GitOps, in my honest opinion. It's the most interesting point of all this workflow of GitOps, is that it must be continuously reconciled. Sorry for my English. I'm native Portuguese, and it's a bit rough, my English, but I think it's understandable, okay? And I'm talking a little bit too fast because I'm a little bit too nervous. So continuously reconciled means that software agents continuously observe the actual system state and attempt to apply. So what this means is that our operator, our system, we are here talking about Argo CD, will continuously monitoring and seeing what is happening on the infrastructure. Not only on the repo code, but as well on the infrastructure. And we'll see that in the scenario that I have prepared to see it happens in real time. So for that principle, we choose, of course, Argo CD as well, because he do that job greatly, if you know. So here, a quick recap. So it must be declarative, it must be versioned, it must be pulled automatically, it must be continuously reconciled. That is the four main pillars or principles of a GitOps methodology, a GitOps workflow, and a GitOps framework. And we can apply this to anything, to our applications, to our infrastructure, to our service that we are managing. By services, I have talked before third-party services. I'm talking about infrastructure as a service. I'm talking about database as a services, and so on. So, the tools. We are using Argo CD. And Argo CD is a declarative GitOps continuously delivery tool for Kubernetes. I choose Argo CD. I could be talking here about Flux. It's the same thing. Conceptually, it's the same thing. It's not by any means different. It's a different tool, of course, but different features now and there, but conceptually is the same tool. Important here is to understand the role of the tool and what we want to achieve. Okay. For the other part, or for the managing and deploying infrastructure, I choose, and perhaps it's the only one tool on the market, or if not the only one, perhaps the most knowing one tool on the market, that is Crossplane. And Crossplane is a GitOps-based infrastructure as a code through Kubernetes. We know many other tools that do infrastructure as a code, as Terraform. Well, we could fit Ansible now and there here too. It's more a configuration tool, but Terraform could be here, Pulumi as well. But what we want to achieve, the right tool here is Crossplane, just to make sure that we can do GitOps from one side to another, or from end to end. So Crossplane uses a concept of providers. These providers will install some CRDs in our Kubernetes. CRDs is known as custom resource definitions in our Kubernetes. These CRDs is required to create resources on the provider. So, recap Crossplane, it works with providers. Providers are cloud APIs, Azure API, Google API, or any other API, not only cloud. It could be a Cloudflare, which is a DNS service. It could be even VMware if you want it in on-prem. So these CRDs are required to create resources on the provider. So we must have this CRD, this custom resources that is installed by Kubernetes, by Crossplane providers, to allow us to deploy infrastructure in the cloud. We have the provider configs as well. Providers configs are the resource that will map a secret with our credentials on the provider to the provider itself. Okay, so that is one more resource important on the Crossplane architecture. And from here is just read the documentation and do create the YAMLs to provide the resources that we want to deploy on the cloud. So we have a scenario prepared to show us GitOps in action, and in the scenario we'll deploy applications, our applications, infrastructure, which will be a Kubernetes cluster, and we'll deploy services that in our scenario will be database as a service. It will be a MySQL on the cloud API. For the scenario, it will be Google Cloud. So the deploy scenario, we'll see, will be this. This scenario will have a repo that will contain the manifests or the code to our applications, our infrastructure, and our services, and we'll have a Kubernetes cluster that will have the CRDs that I'll talk before to our infrastructure and our applications and even our database. So the main concept here, and just to go in the right direction, is to make sure that the desired state, that what we have configured on the repo, on the Git repo, will be always equal to the actual state that will be the state that we want to achieve on our cloud. So from there, we will have Argo CD. Argo CD will constantly pulling any changing that will be happening in the repo, and will constantly connecting or in connection, in communication with the Kubernetes API to ensure that these resources or these states are always equal to the states that we want here. In other words, the desired state will be always equal to the actual state itself. Argo CD, it will be installed in any Kubernetes server. It could be the Kubernetes that we want to deploy. It could be our Kubernetes. It could be any Kubernetes. In this scenario, I will use my machine, but it could be a cluster, a Kubernetes cluster deployed anywhere. Argo CD, like I said, will constantly be pulling our repo. The default time of this pulling will be 3 minutes. In this scenario, I changed that time to 30 seconds to be more effective and so we can see the changes moving faster, even if sometimes it's not only 30 seconds. Sometimes it will extend by 30 seconds. So we'll have Argo CD and we'll have Crossplane. Crossplane will have already defined the resources that we need. So I have already configured this part of the scenario. Okay, I will not do this online. I'll have already this check, but I'll run some commands for you to see. Argo CD will be connected to a cloud provider, which will be Google Cloud, and we'll have defined 2 types of resources: a Kubernetes cluster and a service, database as a service cluster. It could be, like I said before, if I have more providers, it could be a DNS record on the Cloudflare or anything more. Here, it's our CRDs, our custom resources definition that we want to deploy. So Crossplane will see and will check these resources. This will be a YAML file that is defined or that have defined our Kubernetes cluster, and this is a YAML file, is a cluster resource that a Kubernetes resource, sorry, that will have defined our database as a service. Crossplane will know that CRDs, of course, and then we'll have a provider. Crossplane will contact the provider, and knowing our CRDs, will talk to the cloud provider and we'll say, okay, deploy a Kubernetes cluster and deploy a database as a service. So from here, this is what is prepared right now. I will show you. And from there, we'll do some GitOps, some modifications and some removes or deletes of our infrastructure. I'm not bringing here a creation of a full infrastructure because this takes near 5 to 10 minutes or more, and will be useless. We be here waiting for the infrastructure to be created. So right now, I will move. Just 1 moment. Okay, so first things first, our Argo CD and all resources that are installed on our cluster. Okay, this is the different pieces of Argo CD, replica sets, deployments, and well, it's a common Kubernetes application. Not much of a secret here, just behind the scenes. And okay, in the Crossplane side of things, we can check the providers that we have installed. Here on my machine, I have the Google Cloud provider and I have the Azure provider. I could have many more. For this example, I will only have these 2 providers. And I have as well our infrastructure that I will show you in a bit. So this is a different kind, it's a custom resource of a Kubernetes. Like you're saying, I'm relying only on kubectl to bring these resources to me. And from here, I can say, I can check that I have a GKA cluster, so a Kubernetes cluster running on Google Cloud, and it's up and running already since 8 hours ago. Like I said, I have already provisioned this infrastructure for the show, for the talk. And the other thing that we have already defined, it's our cloud SQL instance. That will be a MySQL instance. So this is our resources already defined on our Kubernetes server. So from here, we just apply the project or our YAMLs to Argo CD, and Argo CD will take care of the rest. And for that, I will show you my Argo CD implementation. I think that will move it. Okay. So this is Argo CD. A little bit bright, I guess. Can you see it? I don't control the projector. So here in Argo CD, we have a project. In our case, my project will be a production environment. And a project will be a logical representation of accesses, which destinations I can deploy from this project, and so on. So it's a logical representation or a logical isolation of an ambient that I can, through control, and do RBAC and access control based. Okay. And I have our applications that I have in my repo already defined. So here I'm using one strategy that we could use in Argo CD, which Hub of Apps. We have many strategies to deploy through Argo CD. I have Hub of Apps and I have my Argo CD already defined on the cluster. So these two applications, this is a placeholder applications that glues all our applications, all mine applications, and this one is my representation or my custom application of Argo CD. From there, I have all my infrastructure that is already deployed, and one application is with the status unknown. We go there in the sec. So we have GeekSessions DB, which will be our SQL instance, my SQL instance, and we have a Kubernetes cluster, which will be our Kubernetes cluster. Just to make sure, or to show you that these resources is already deployed, I have my Google Cloud here, and we can see that I have here a SQL instance that is green, so green here is okay, only here. And I have my Kubernetes cluster up and running as well. So I deployed this infrastructure to a Git push to my repo. Now we want to make some changes to this infrastructure, at least to make this app running. So this app is in the state of unknown, and well, we wanted that application be green, so healthy and synced, and let's do it. So first of all, the main problem here is because that I have the destination cluster of my application, and by this application I'm talking my application, my code, my personal code. I must say it's a React app. That I have done here only for the GeekSessions, and what we're gonna do is to fix that IP address that is not the IP address of our destination cluster. So here is my code. I'll try to do a zoom as well. Okay, nothing more. Okay, weird. Okay, nice. Nice, a bit too much. So, looking at our code, what we have here is our project. It's here, our project that I have deployed on the Kubernetes, and all the definitions that I have set to them. So I allow it to deploy in any namespaces. I allow it to deploy on any Kubernetes clusters, and so on. And we have our apps. Like I said, it's a strategy that you could use on Argo CD that is apps of apps. From there, I have my code, which will be GeekSessions app, which is a normal application. You know it. You see the kind of files every day. I have my representation of applications in Argo CD, okay, my CRDs of Argo CD, my application of Argo, my application of my database, my application of my application, and my application of representation of Kubernetes cluster. So from there, I have Here I have my application, and my application, it's a simple deployment YAML with horizontal autoscaler as well, and I think a load balancer or not. Well, it doesn't matter here. Sorry?
This the top seem that one online first, yeah, that one. Those seem like they will be the responsible for scaling.
Yeah, the horizontal autoscaler, yes. The autoscaler that I have defined here is just to maintain a minimum of 2 replicas. Yeah, it's just a normal Kubernetes resources that you have already seen in so many deployments with autoscaler and with the deployment. I have my DB, which in this case, it's a different kind of resources. Like I said before, it's a custom resource definition. And in this case is the Cloud SQL instance. And any more definitions. And we have our cluster. and it's just like that. Yep, it will be, as I said before, a Crossplane CRD2, it's a GeekEA cluster, and it's a node pool for our GeekEA cluster. So now our task is to update our IP of destination clusters so we can deploy our application. From there, I will go to our Kubernetes. I can check here my endpoint, okay? But I could do it from Argo as well because I have already inserted my cluster in Argo CD, so this is IP of our cluster. Is that IP that I will update. Oh, different strategy. And
Missing an 8?
8. Yeah, it's that, I guess. Yes. So, I've made a change. Now, the only thing that I have to do to deploy my application will be git push. In this case, I will add this file. And I'll do it a normal git push using conventional commits. Fix IP address, okay, it works.
That's it.
And I do it a git push. From this time, from there, my Argo CD will be constantly, every 30 seconds, looking at my repo and will eventually, in the next 30 seconds, get the change and deploy my application. What we can see now, while we wait, it's the reconciled, or the four principle, the reconciliation of resources. So the maintaining of the desired state always. So here, I go to the Google Cloud, I go to my SQL instance, and I will do it exclusion. So bye-bye. I will be writing. It's
The text selection
Yeah.
there is very hard to see.
yeah.
If you use this screen, you'll see it.
So right now I have excluded my database, and that could be a problem if we are not using GitOps. But since we are using GitOps, in the next 30 seconds, 1 minute or less, our database will be recreated. If we are using a normal or a conventional CI/CD pipeline, that couldn't happen. You know, if I have deployed this SQL instance by Terraform, right now I have to go to my pipeline and run the pipeline again. So Terraform will check the changes, will do the plan, will check the changes, will notify me that anything changed on my infrastructure, and if I want to apply. So it's a more manual process. There are tools to make it automatic, but for this specific scenario, I think GitOps is a better approach than the conventional CI/CD. So let's go back to Argo, just to see if anything had changed already or not. Okay. Something had changed. At least it notified that is out of sync, and now it's syncing. Okay, I haven't done anything. I just do an update of the IP address. So if you can see in my application here in Argo CD, we'll check that the last commit I've done to my repo, it's the fix of IP of prod cluster, And by this time, I am deploying my application to my cluster. If everything goes right, the application will be up and running in a few seconds. It's healthy, which is good. Go there in a second. Let's see here if anything changed here or not. Okay. It's telling me that is an instance being deployed, which is good. So I can see any details by this moment, but, well, we'll be back in a second. Our application, let's see it, how it's there. So I have deployed in the Kubernetes, so I will use here get contests. Oh, wow, too many contests. Use contest, and I think it's that contest right here. Just a second, please. Wait. Let me just do a copy paste really fast. I promise that nothing is going on the backwards, okay? Nothing happening backwards. So I lost my terminal. Where is he? Where is my terminal?
It's below. Yeah.
Is it below?
There's the top bar below.
Oh.
If you alt tab or something.
Command tab.
Oh, okay.
There you go.
That's it.
Okay. Okay, right there. It was just to copy the name of the contest. So let's do a quick check in our application. So our application will be right here, and our deployment will be in the namespace production, I guess. GeekSession, okay. Okay, yes. So I have a namespace named production, built 3 minutes ago, which is good. So let's get out of our production. And yes, we have our application, 2 replicas, a load balancer, which is good, the deployment, replica set, horizontal pod autoscaler, and let's see our IP. And hopefully it's up and running. So this is a way that we can manage our infrastructure. So we have checked that by deleting our SQL instance on the cloud provider, that instance will be recreated as soon as 30 or 3 minutes. And we have already checked that by deploying a push, a modification of our application, that our application will be changed and is up and running. If we want to remove anything or any resource on our cloud provider, we have already checked that we can go to the cloud provider. We have to remove it from the repo, and then the resource will be destroyed itself on the cloud provider. We can do that, but I think you all already get the idea of the GitOps thing. So I will do a quick remove. It's not a git remove. It's a remove of my, not this one, but I will remove our database. Okay, git status, and I will remove this from my repo. Git commit. Now it's a fixture. Removed infra, not from Azure. Removed infra, DB, MySQL, GCP. Okay, git push. And you can see our log, which will be remove the infra. Now, going back to the Argo, and we'll see that this resource will be removed from here, eventually, and from here. And is that so?
Just a quick question about that. You mentioned it's 30 seconds.
Yeah.
The watch window for Argo CD. Is that something that you have configured? Is that something that is fixed for every resource, or does it cycle through them and all of them in different times?
Yeah, it's for any resource on Argo CD. I have fixed them on 30 seconds. The default is 3 minutes. Okay. Nothing. I don't think that more could be achieved by or more frequently. Yes, we can deactivate it permanently.
Per resource.
No, it's globally.
So it's global.
From what I know, it's globally. Okay, so because you are telling the Argo CD to check in for all resources in X seconds. So eventually our database will be removed from here and cleared from here.
It was just added.
Yeah. Google is what? What do you want it? So database, it's removed from